Okay, we're continuing with probability notes, and I'm going to talk about different probability rules and how to make probability trees. So let's start with some definitions. Again, make flashcards of these. First, let's define sample space. Sample space is the collection of all possible outcomes of a chance experiment. So for example, this sample space, if I were to roll a die, would be all my options, typical die, 1, 2, 3, 4, 5, or 6. Again, your sample space, if I flip a coin, a normal coin should have heads and tails. An event. An event is any collection of outcomes from the sample space. So event of rolling a prime number, while I have the option of 1, 2, 3, 4, 5, or 6, the prime numbers are only 2, 3, and 5. So complement. Complement consists of all outcomes that are not in the event. You could also think of it as 1 minus the probability of the event, because it's the not part, so 1 minus. So what would be the complement of not rolling an even number? That would be all your odds, 1, 3, and 5. And again, notation, if you're looking for complement, is this little superscript C. So Venn diagrams can help us determine probability, and Venn diagrams are a great way to visually represent probabilities. So the intersection of events A and B, given this notation, is the little upside down N looking part, is the set of all outcomes in both events A and B. So intersection, think and. Intersection, think and. They are common to both, the overlapping part. The union of events A and B, denoted by a U, is the set of all outcomes in either event A or B. So union means or. And one way to remember, again, union starts with a U. Okay, union or, one or the other. Intersection has the second letter of N, and it is and, has to be common to both. So what does it mean to be a mutually exclusive? Could also be called disjoint. This means that two events have no outcomes in common. It's impossible to occur together. So for instance, if I have a normal die rolling a 2 and a 5 at the same time, it's not going to happen. I either roll a 2 or I roll a 5. If we think about visually in a Venn diagram, what a mutually exclusive or disjoint Venn diagram would look like, there's no overlapping. They can't occur at the same time. Independent are when two events are independent if knowing that one will occur or has occurred does not change the probability that the other occurs. So independent is often confused with mutually exclusive. Independent events can occur at the same time. It just means that the probability is not affected. So if a randomly selected student is female, if I know they're female, what's the probability that she plays soccer? Well, this would be an independent event. Okay, I'm not going to change the probability of her playing soccer knowing that she's female. But let's think about the second one. If I tell you that the student is female, are you going to change your answer for what's the probability she plays football? Well, yes, schools are often changing and allowing all genders to play football. Typically, males play football. So if I tell you that she's female, your answer to what's the probability she plays football is probably 0. So this would be not independent. The probability would change if we're saying that females are not allowed on the football field. But yes, I know many schools are changing that rule. So basic rules of probability. Okay, the probability of an event is a number anywhere between 0 and 1. The sum of all probabilities has to be equal to 1. And if all outcomes in the sample space are equally likely, the probability that event A occurs can be found using this formula. the number of outcomes corresponding to event A divided by the total outcomes in the sample space. Probability that an event does not occur is 1 minus the probability of the event occurring. Again, that's definition of complement. And if two events have no outcomes in common, the probability that one or the other occurs is the sum of their individual probabilities. So some additional rules. Again, as we've always said, probability is either a number between 0 and 1, not smaller than 0. 0 means it can never happen, not greater than 1. 1 means it's going to happen every time. Your sample space, again, has to total 1. Again, complement means 1 minus, which means your probability of the event plus the probability of not the event has to equal 1. And we have two additional rules, addition rule, multiplication rule. So if we have two disjoint can't occur at the same time events, no overlapping region, the probability of event E or event F happening would be adding. So if we have an or, we're going to add the probabilities. Again, straight adding is only if they cannot occur at the same time. Well, if they can occur, if they're not disjoint, they can occur at the same time. Well, that means that we have an overlapping region. If I account all of E and all of F, well, that means I'm accounting for that overlapping part twice. So I need to subtract one of those overlapping regions out. So probability of E plus probability of F minus one of the overlapping probability of E and F. So multiplication rule, what if I want to find the probability of A and B? Well, keyword and probability means multiply. So if they are two independent events, probability does not affect each other. You're going to straight multiply the two event probabilities. But if they are not independent, which means the probability could change, you're going to take the probability of A times the probability of B given A, and we'll do an example of that in a minute. The key thing here, probability or equals add, except if it's overlapping, subtract 1. Probability of and equals multiply. Distance learning courses are rapidly gaining popularity among college students. Randomly select an undergraduate student who is taking distance learning courses for credit and record the student's age. So here's the probability model based on the ages and the probability. So show that this is a legit probability model. Well, to show that it's legit, we need to show that the sum is equal to 1. So if we add up all of our sample space, 0.57 plus 0.17 plus 0.14 plus 0.12 does indeed equal 1, and no probability is less than 0 or greater than 1. So find the probability that the chosen student is not in the traditional college age group, 18 to 23. So multiple ways we could do this. We could add everything except the 0.57, so 0.17 plus 0.14 plus 0.12. Or we could do it as the complement, 1 minus the 18 to 23. Either way, we get a probability of 0.43, or 43% of the undergraduate students are not 18 to 23. Let's do some more examples. Musical styles other than rock and pop are becoming more popular. Survey of college students finds that the probability they like country music is 0.4. Probability that they like jazz is 0.3. And that they liked both is 0.1. So what is the probability that they like country or jazz? Well, or means add, so probability of country is 0.4, probability of jazz is 0.3. But given that we know that both liked 0.1, well, that means this 0.1 is included in 0.4 and the 0.1 is included in 0.3. So we need to subtract one of those 10% out because this 10% is accounted for both. So if we subtract it out, we get a probability of 0.6 or 60%. Here we have light bulbs. A certain brand of light bulbs are defective 5% of the time. You randomly pick a package of 2 such bulbs off the shelf of a store. What is the probability that both bulbs are defective? And can we assume that they are independent? Okay, so if I have information about the first bulb, and is that going to tell me information about the second bulb? Does the second bulb being defective affect it? Well, these would be independent, okay? Even if I know the first one's defective, that wouldn't affect the answer. It shouldn't affect whether the second one is. So since we have probability of and both are defective, we're going to multiply. So probability defective is 0.05 times probability that the second one is defective is 0.05. Crunch the numbers, we should get a probability of 0.0025. So very, very small, which should ring true because if you're buying a package of bulbs, there should be a very small chance that you get to defective. So let's look at a card example. Suppose I will pick 2 cards from a standard deck without replacement. What is the probability that I select 2 spades? Now, AP Test does require you to know about a deck of cards. You need to know that there's 52 cards in a deck. There are 4 suits, okay, 13 cards in each suit, okay? You do need to know that. Half of them are red, half of them are black. So are the cards independent, okay? If I do not replace without replacement, I'm drawing a card and I'm not putting it back in the pile, well, then it is not independent, okay? I'm removing a card, so that is going to affect my second probability. So what is the probability of A and B? Probability of A and B equals the probability of A given the probability of B given A, okay? So since I'm not replacing, I need to do my given probability. Well, what is the probability that the first one is a spade? The probability that the first one is a spade is a fourth, right? I have 4 suits in a deck, or you could say 13 out of 52. And since I'm not replacing it, I don't have 52 cards anymore, I have 51. And if I've already drawn a spade, I don't have 13 anymore, I have 12. So again, 1/4 is because we had 13 out of 52, so you can simplify. Multiply top times top, bottom times bottom, and we get a value of 1 out of 17. So again, pay close attention to whether, if they're talking about a deck of cards, is it with replacement or is it without? If this was with replacement, we would have 13 out of 52 as the second fraction. So back to our light bulb question. A certain brand of light bulbs are defective 5% of the time. You randomly pick a package of 2 such bulbs off the shelf of a store. What is the probability that exactly 1 bulb is defective? Well, here we can do what's called draw a tree diagram. So let's think about the first bulb. The first bulb, I have 2 options. It could be defective with a probability of 0.05, or it could be ND not defective at a probability of 0.95. And my second bulb, again, I could have defective for probability of 0.05 or not defective. And again, I could have the first bulb not defective, but the second bulb could still be defective, 0.05, or not defective, 0.95. So here's what we call a factor tree, a probability tree. So what's the probability that exactly one is defective? Well, let's circle which one is exactly one defective. That's defective, non-defective, and not defective for the first and defective for the second. So we can write out, we are multiplying 0.05 times 0.95. You multiply across the tree plus our second circle, 0.95 times 0.05. Put that in your calculator, crunch the numbers, we get 0.095. So about 9.5% that one is defective. So same scenario, what is the probability that at least one is defective? So again, we have the same probability tree. At least one would mean it could be defective then not defective. It could be defective, defective, and it could be not defective and then defective. So the only thing we are not including are two not defective, or two working bulbs. So let's add up our probabilities. Again, multiply across your probability tree. You get 0.05 times 0.95 plus 0.95 times 0.05 plus 0.05 times 0.05. Crunch the numbers, we get 0.0975. So the probability of about 9.75%. So what about this scenario? We have a video sharing sites led by YouTube, our popular destinations on the internet. Let's look only at adult internet users aged 18 and over. About 27% of adult internet users are 18 to 29 years old. Another 45% are 30 to 49, and the remaining 28 are 50 or over. The Pew Internet and American Life Project finds that 70% of internet users aged 18 to 29 have visited a video sharing site, along with 51% of those 30 to 49 and 26% of those 50 or older. So two questions here. Find the probability that this person has visited a video sharing site. And given that this person has visited a video sharing site, find the probability that he or she is aged 18 to 29. So most of the time when you have this many percentages, this is your clue to make a probability tree. So here's what your tree may look like. Notice the first piece of information it tells us is that we have 3 age groups, right? 27% are 18 to 29, 45% are 30 to 49, and 50 plus is 28%. Okay, next it tells us how many have visited. It said from the 18 to 29, 70% have visited, which means if we subtract that from 100, 0.3 have not. From the 30 to 49 group, 51% have visited. Subtract from 1, 49% have not. And from the 50 plus, 26% have visited and 74% have not. Okay, so if you have one part of the tree, subtract from 1. Now that we have our tree, we should be able to easily answer our questions. Find the probability that this person has visited a video sharing site. Well, has visited, visits video sharing site would be from our 18 to 29 group, right? Has visited from our 30 to 49 group, and has visited from our 50 plus group. So if we crunch the numbers, we got 0.27 times 0.7 plus 0.45 times 0.51 plus 0.28 times 0.26. And that gives us a total probability of 0.4913, or we could say about 49.13%. So let's look at our second question. Given that this person has visited a video sharing site. Find the probability that he or she is aged 18 to 29. This keyword given means fraction. Given means fraction, okay? So since we're only talking about now from 18 to 29, given 18 to 29 means the probability that I just found, 0.4913, is on the denominator. So given denominator, given probability goes in the denominator. So find the probability that he or she is aged 18 to 29. Well, we find that as our first circle, 0.27 times 0.7, but given goes in the denominator. Crunch the numbers, we get 0.3847 or about 38.47%. And there are your notes on probabilities.